Hey there, Mr. Sutton here with the Pre-Cal Honors 9-2 Part 1 homework solutions on intuitive infinite limits. For this problem, we're answering a few questions about this f graph over here. So let's see, we've got the limit as x approaches 4 from the left. Well, here's 4. As I approach that from the left side, that's giving me a y value of 1. And now 4 from the right side, as you approach from this direction, you're still getting a y value of 1. And now the overall limit then of 4, since these two limits agree, is also 1. F of 4, that's the actual value of the function, while the solid part of the graph is at the y value 1. So that's also going to be the same as the limit. All right, so moving on now, we've got the limit as x approaches negative infinity. So as we move to the far left here, we're going down forever. That's negative infinity for that limit. And then as x approaches positive infinity, well, to the far right, we're going up forever, so that's positive infinity for that one. For this problem, we've got parts A through F for the F graph here. So first question, as x approaches 0 from the left side, that's coming from this direction at 0. That gives us a y value of 3. From the right side, if you look here, it's going to be the same y value. And then from both sides then, since the limits agree, it's going to be 3. F of 0 is also 3. The function value is 3 at x equals 0. And then finally, these other two questions, as x approaches negative infinity, as we move to the far left, now we see that we are moving up forever, so positive infinity. And same thing as you go to the far right, your y values are increasing without bound, so infinity for that limit as well. For this problem, we're using this graph over here to help us answer these limit questions. For part A, as x approaches negative 2 from this is the left side here, as we approach from the left side toward this asymptote, we're going down forever. So that's negative infinity for that first limit. For the next one, as we approach negative 2 from the right side, it looks like if we follow this, we're going up forever. So that's positive infinity. And then the overall limit as x approaches negative 2, well, the left and the right limit don't agree. So this is definitely DNE. If they were at least going to the same infinity, then we could write that infinity here. It would still be kind of just DNE with direction, but it would be more specific. Now for this one, f of negative 2, the function is undefined on this asymptote, so that's DNE. For part E, as x approaches negative infinity, as we move to the far left, we are following this asymptote right here at y equals 2, so 2 is the limit as we go to the far left. And then as x approaches infinity is where you go to the far right. Let's follow that here. We appear to be approaching the x-axis, so asymptote at 0. So 0 would be our limit for that one. On this question, we're using this very interesting graph of f to answer these limit questions. So the first one, as x approaches 3 from the left side, so here's 3, it's this asymptote here. As we approach from the left side, we're going down forever, so negative infinity for that. And then as x approaches 3 from the right side, looking at the right side here, we're still going down forever as we approach that asymptote, so still negative infinity. Now as x approaches 3, the two-sided limit, well, it's an asymptote, so there is no limit technically, but since they are approaching the same infinity from both sides, we can write negative infinity if we want to be a little bit more specific about the type of does not exist. And now f of 3, this is the most interesting one of all. That's wherever you have a solid dot or line at x equals 3. Now normally on an asymptote, you have an undefined function. But this is a little bit weird. We have a solid dot here at y equals 1. So that is actually the value of the function there. And you might be wondering, because this kind of flies in the face of everything we've learned about asymptotes, how a function can be defined at an asymptote. Well, this is most likely a piecewise function that there's one kind of function that's giving us these branches here, or maybe even two functions. But for this one little spot, there's probably a rule that says y equals 1 when x equals 3. All right, moving on. As x approaches negative infinity, as we move to the far left here, we went over this horizontal asymptote, but now we are approaching it from the above here. So that's going to be y equals 2 for that limit. That's the y value of the asymptote. And then as x approaches infinity, moving to the far right here, we're approaching that same asymptote, just going the other direction, so still 2 for that limit. On this problem, we have this weird-looking graph of f to find out some limit information about. So for part A, as x approaches 0 from the left side, let's look at 0, the y-axis here. Approaching from the left side, we're approaching the y value 1, so that's the limit for part A. For the next part, as we approach 0 from the right side, so we're following this branch now down here, and we're going down forever, so that's negative infinity. And then the two-sided limit of 0, well, left said 1, right said negative infinity. They don't agree, so we're going to write dne for this since the left and the right don't agree. Now for f of 0, that's wherever you have a solid line or dot at the x value 0, the function value. Looking at the y-axis, we see there is a solid dot on negative 2, so that's the actual value at f of 0. And then we've got our infinity limits here. As x approaches negative infinity, as we move to the far left, we're going up forever, not very steeply, but we are going up forever in terms of y values, so positive infinity for that left side limit. And then for the far right limit, as we go to the positive and infinite direction on the x-axis here, it looks like our y values are going up forever, so that would be positive infinity as well. On this problem, we have this crazy-looking graph of f to find out some information about with limits. First one is x approaches 0 from the left side. So approaching 0 from the left side, we're coming to a y value of 3. It's actually the same as we approach from the right side, so that also answers part B. And since these two limits agree, the overall limit as x approaches 0 is 3. F of 0 is also 3 because the graph does exist and is at 3 for the y value when you plug in x. Now here's where it gets a little bit more interesting. We've got the limit as x approaches negative infinity. So it looks like as we go this direction here, the graph isn't really getting any closer to the x-axis. It just kind of keeps oscillating back and forth. So because we're oscillating, that means that the limit does not exist. We're not approaching a single finite value. We're not veering off into infinity. As far as we can tell, this just keeps repeating kind of the way this graph's set up. But since you're not approaching a single value, we can't say there's a limit. Now, as we move to the far right, different story, we are getting closer and closer and closer to the x-axis. So although we are still oscillating, we're doing so in a decaying fashion. We're converging on a single number, even if we never actually get there and stay there. So that's going to be 0 for that limit, the x-axis. For this problem, we're going to use this graph of f to answer these questions. So first question, as x approaches 0, two-sided limit. So here's 0. As we approach from the left and the right sides, we're approaching the y value 1, so that's the limit for that first one. B now, as we approach negative infinity, it looks like as we go to the far left, we're approaching this asymptote at y equals 2, so 2 is the limit at negative infinity. As we approach positive infinity, we're still approaching y equals 2 just from the top here as we move to the far right, so that also has a limit of 2. Now for this one, as x approaches 1 from the right side, that's a little plus sign there. Well, here's 1. We have a vertical asymptote. As we approach from the right side, we're going up forever, so that's positive infinity. And now as we approach 1 from the left side, we are going down forever, giving us negative infinity for that next limit. And then finally, two-sided limit at 1. Well, since we're going to different infinities, our limits don't match up, and this is just a straight-up DNE. Even if they went to the same infinity, it would technically be does not exist, but we could be more specific and say it was negative or positive infinity. Since it doesn't even go forever in the same direction, no, this is just pure DNE right here.